with this subject about FGF4 retrogenes, and then Vilma will also, as I said, tell you an aspect about this, which is very familiar in other breeds, for instance in duckhounds, but is now also quite apparent in Skye Terriers. So I'm going to tell you how do these retrogenes affect the appearance and health of Skye Terriers, and what to do possibly then next. So I start from the beginning. As I said, I'm a teacher, and I want my students to understand what I'm talking about. And this is the reason why I'm just very briefly showing you this complexity of the genome and genes, what we are talking about. Because if I'm not talking about this, you don't understand what retrogenes are and how they are affected. So this beautiful molecule of DNA has a very specific construction. It contains two bases that are connected to each other. Actually, there are four of them: adenosine, thymine, guanine, and cytosine. And they are making kind of a structure that is bond together. And then there is a sugar phosphate backbone also here, which is stabilizing the structure. And one of these units here is called base pairs. And dog genome contains 2.5 billion of these base pairs. So we are talking about quite like a substantial structure. And then this marvelous molecule is making this kind of a double helix. And this double helix, if we take all the genes and DNA from dog, from one individual, from all of its cells, and start to climb these stairs, we can go to moon, 2 times around the moon, and then we can walk back. So we are talking about a huge construction in a dog, and also in us humans. So what is made of this wonderful molecule? It's an instruction for proteins. And proteins then, on the other hand, they are building blocks for every organism. They make up, for instance, in us and in dogs, bones, teeth, hair, muscles, internal organs, and so on and so forth. Of course, there are other things. Most of the body content is basically water, and then there is unfortunately fat. That is also something that we have to take into consideration. But proteins are important, and they have multiple functions. They are antibodies, they are enzymes, they are cell signaling molecules, they are all kinds of different functions. They are used for structure, function, regulation of the body, everything. Proteins may be large or small, but they are all made according to the instructions written in these base pairs of the DNA. Dog genome contains approximately a bit less than 20,000 genes. And each of these genes encode according to this base pair sequence. These bases are like in different sequences in different genes. They encode for one or several proteins or parts of the proteins, which are called polypeptide chains. We could say that the DNA is some kind of a cookbook of life. And these recipes in this cookbook are used when needed. Most recipes in this menu are used during the embryonic development. And for instance, I'm developmental biologist in my profession, which means that I'm studying embryonic and fetal development. And this is the reason why I also have been involved in many of these genes that are taking care of embryonic development. And then many of these recipes that are used during the embryonic development and fetal development, and also in dogs during the puppy life, they are not needed in the adult organism anymore. They are not needed in adult dog. But there are new ones that are then taken from this cookbook, new recipes when needed. And for instance, one situation when these new recipes are taken into the menu quite quickly also is when, for instance, immune system is activated. In stress, there are changes in the body which are conducted by hormones, and then hormones are regulating the genes, and the genes are then regulating the protein expression. During the heat cycle, for instance, in bitches, you know that it's not only the heat cycle. I mean, there are like their characters are changed, like their behavior is changed, their body is changed, and it's all because of these changes in the cookbook. But then, what is quite remarkable is that dogs with the most genetic diversity also have most recipes available. And then when the genetic diversity, which we are talking about also today, when it is decreasing, we lose these recipes, and we lose these proteins, and we lose these functions. Okay, now we are looking at the video, I hope. Very short, but many times these videos are telling you more than 1,000 words. This is a cell. This is a human cell, but dogs have exactly the same cells. And now we are going into the cell. In the middle of the cell, there is this central piece, like brains in the cell, which is nucleus. Now we go into the nucleus from a hole. And there are chromosomes, and DNA is packed to these chromosomes. And the packing units are here. They are histone proteins, and now we are opening this packing. And here's one gene. And these are the bases here. And what happens next is that there is a protein machinery that comes there. This is called an RNA polymerase. It opens the DNA, and then there is a copy made according to these pairing bases from this gene. And now the gene is copied. And this process is called a transcription. And then when we get the copy ready, this copy is called a messenger RNA. It's modified. There are pieces that are taken out, and there are a bit more other modifications also. And when these modifications have been done, this messenger RNA comes out from the hole of the nucleus to the cell cytoplasm, and there is another protein machinery there. These are called ribosomes. And now these ribosomes are starting to read this messenger RNA. And along is brought amino acids, which are the units of the proteins. And these transfer RNAs are bringing 3 bases at time. And now they are reading this copy of the messenger RNA, and this reading process is called translation. And now we get these amino acids. This is a polypeptide chain, which is taking place here. And then it's having a three-dimensional structure, and voila, there we have a protein. And this process goes on and on and on in the body. When you are sitting there, this process is ongoing in your cells. And so it is in dogs. Okay, now you know everything about gene. Okay, I take an exam.
I know that.
I take an exam in the afternoon. Okay. Now then, retrogenes and FGFs. What are these retrogenes? First of all, there are in the body jumping DNA elements. And these jumping DNA elements are called transposons. And they are able to jump to a different location in the genome where they originally have been. And they can integrate as a part of the genome. And obviously, because there is something extra coming there, the sequence is changing. And then also the message is changing. These beautiful elements were found of one of my favorite idols, Barbara McClintock, who was an American Nobel laureate. And she was studying various colors in a copse of corn. And then when she found these transposons. Nobody believed her. She was like taken as an idiot first, which is quite normal. But then in the end of the day, she was decorated in many ways. And she's one of the famous persons in the history of science and genetics. So she found these elements, and that they could move around to different locations in the genome of these cords and change the color of the cords. These kind of jumping elements, transposons, they occur in different forms. And retrotransposons are possibly elements that are derived from retroviruses. And viruses are something that also are able to integrate the genome, jump into the genome, and change the genome. And it may be that this is only one theory, that these transposons and retrogenes are derived from retroviruses. Viruses are not always bad. They are bad sometimes, but not always. Okay. So retrogenes are considered to be these transposable elements. Before retrogenes were considered to be so-called pseudogenes, that they are like junk. They don't have any role. They are not changing anything. They don't have a function. But now we know that this junk is no junk. It may have a significant role in evolution, normal cell function, and in diseases. Some of these retrocopies can even be expressed to produce functional copies of proteins, and this is what we are now talking about. What are FGFs? FGFs are a family of proteins, fibroblast growth factors. They have many functions. They have many functions, especially during the embryonic development. I have been studying FGFs for ages because they are so important in embryos, but they may also have a role in adult organism, and especially in diseases, and for instance they have been found from many types of cancers. One of the functions is to regulate bone formation and bone turnover. FGFs, they are proteins, they bind to another protein in the cell surface, and these proteins are called FGF receptors. And this binding activates multiple responses in the cell. Activating or inactivating so-called downstream genes. So when FGF is, the signal is coming to the cell genome is either activated or inactivated, and there are multiple genes that are regulated by these FGFs. And as a consequence, the behavior of the cell is changing. This is how bones, these longitudinal bones in dogs and our body are formed. They are derived from undifferentiated cells, mesenchymal cells which are undifferentiated, and first they are forming a cartilage, like a model of the bone. And then this cartilage is replaced in step-by-step manner by another type of cells, and these cells are called osteoblasts, and they are becoming those that are then calcified and becoming hard bone. And this process starts during the embryonic development, and it continues during the puppyhood of a dog, as long as this growth plate here is active. And in this growth plate there are these hypertrophic chondrocytes that are still able to get the bone longer. And FGFs are one of the genes or proteins that are regulating this process. Especially this phase. And now, if we have an FGF retrogene in the genome, and it's going to be expressed, there is going to be an extra copy of FGF. And what it causes, it's too much. And what it causes this cartilage to finish kind of before it should be finished. And then the bone becomes short. Very, very simple, very complicated, but simple. Made it simple. How do these FGF then affect the process? So they regulate the formation of the cartilage differentiation and osteoblast differentiation. So the cells also that make the bone. Overactivation of FGF signaling causes in humans a severe and rare type of dysplasia, which is known as thanatophoric dysplasia. One patient is seen here. Thanatophoric means that it's lethal, so these babies cannot live. And one thing why they cannot live is this, that their bones here in the chest are not developed properly, and they cannot breathe. But you can see also that they have tiny, tiny, tiny short bones here. And it's because of this overexpression of FGF. So, this is known in humans. There are also other forms of dysplasias in humans, also caused by FGFs, but this is the most severe one, this thanatophoric dysplasia. And thank God it's rare. But the real surprise came in 2009 when a group of researchers at the National Human Research Institute in the United States found an FGF4 retrogenes from the dog chromosome 18, and this was not a pseudogene because it was expressed, and it had jumped to a position in chromosome 18 where there was a machinery that enabled it to be activated. So it was no joke. And this was one of the very first publications that showed that these retrogenes can be expressed and they have a function. And this extra copy in chromosome 18 in dogs causes chondrodysplasia, which is the short leg phenotype. And this is the reason why our Skye Terriers have short legs. It was shown in many of these chondrodysplastic breeds. Actually, I think all of them. And then it was on the other hand shown in non-chondrodysplastic breeds that there is not this type of FGF retrogene in chromosome 18. And from this on, we have gained more and more understanding about the function of FGF4 retrogene in the chromosome 18 and what kind of things it is causing. And here is a chondrodysplastic breed, which you quite well know, and here is another one that isn't a chondrodysplastic breed. And the only difference in these breeds, there are some other differences because they are different breeds, but the main thing that gives their appearance is this one copy of this one retrogene. So genes may have a significant functions. How do they affect bone development in these chondrodysplastic breeds? Short leg is one, but then in 2017 another study revealed a second FGF retrogene. So FGF4 seems to be a jumping element that is jumping here and there. And now in this case it has jumped to dog chromosome 12. And this new retrogene, which Vilma is also going to show you what it does, causes shortening of the long bones, not quite maybe as much as the FGF4 in chromosome 18, but nevertheless here is a Nova Scotia duck-toning retriever that has this shorter leg phenotype. But then it was also shown that it is associated to the invertebral disc disease in dogs, and then now this chromosome 12 phenotype is called chondrodystrophia instead of chondrodysplasia. And this is why we have these two different types of shortenings of the phenotype. Well, as I said, these two genes, the CDD, the chromosome 12 mutation hasn't been found in all of the chondrodysplastic breeds. So there are chondrodysplastic breeds that have only the chromosome 18 mutation, but then there are breeds who have only the chromosome 12 mutation, and then there are breeds that have both, and our breed is one of them who has both. I have been talking with Danica Panas, who made this latest discovery. There is also a third FGF4 retrogene in dogs. And she found it from Skye Terrier, so yes. but it seems that it doesn't have that kind of a phenotype, and she doesn't know yet what it does. But she has found it. Skye Terriers have been actually one of very important breeds in her studies, because they seem to know all of these things. Okay. So the chondrodysplasia is the short leg phenotype. As far as we know at the moment, it has no effect on spine. So there is no chondrodystrophia in this chromosome 18 mutation. But it, as we have seen, affects the growth of the longicular bones in all legs. Because of this, that the bones are not developing normally, it's an abnormality, it can cause so-called incongruity, especially in the elbow joint, so that the elbow joint is not like perfect. And this is because basically the radius and ulna are growing at different rate during the puppyhood, and then the elbow joint may be misformed. It causes so-called puppy limping. This is the reason for Skye Terrier puppy limping. It's not because they have run too much. And it's not because they have jumped from the sofa. It's because of this. And this kind of a puppy limping, it may be temporary, but it can continue. And then at some point, if there is very much differences from the normal in this elbow joint, the adult or the elderly dogs can start the limping again. And I have experiences, I know. So you should take into consideration that this is not just the short limping problem during the puppy's life. Dog puppies should not be limping. It's not normal for a puppy to limp. It's not normal for the puppy to go to the crate so that it cannot get exercise because of the limping. It's not dog's life. It may also cause osteoarthritis in the elbow joint and also in the wrists, because the wrists are many times also turned outwards quite drastically. It's because of this gene. We have, for this process that we have developed in this country, actually from Skye Terriers, and at the moment all Skies used for breeding in Finland have to be x-rayed for this incongruity before breeding. INC3, which is the most severe in these cases, should not be used for breeding, and they are not used for breeding at all. Our rules are so. And then INC cannot be genetically tested because all Skies are homozygote for this chromosome 18 FGF retrogene, because otherwise they wouldn't be short-lived. So genetic testing of FGF4 retrogene doesn't help here at all. And we don't have any other genetic test that would tell whether the puppy is going to be limping or not. So the X-ray at this point is the only way that we can assess the elbow joint and also assess what kind of a severity the dog is having in its own elbows, plus that, because this is an inherited thing, has the dog possibility to inherit this to its offspring. And obviously we don't want to have limping puppies. So what has happened, we have been doing this, Hanna, how many years now?
More than 15.
Around 15 years?
Yes.
I think.
And believe it or not, we have less in 3 cases now than what we had before. and we have also less in Finland.
And there are perhaps already 5 generations in Finland which has the great knowledge. So it really works. I recommend it.
It works. It really does work. And you can ask Vilma how you can get the scrutiny. Because any vet station can take, we have instructions how to take the x-rays. They are not like normal x-rays taken from the elbow joint. So we have a process, and it's also written in English. We can give it all to you. So if you want to join the gang, you're welcome. So this is something that we don't want to see. And judging the dogs yesterday, I have to say that the fronts have improved. There are not like this, oh my God, cases, so many anymore. Then this, which Vilma is going to tell you more about, this chondrodystrophia. Genetic testing for this is available in different laboratories and in test panels. There are several laboratories that offer this test. US Danish Veterinary Genetics Laboratory collects the test results from breeds with at least 30 test results. Then there is another, this wisdom panel data. It is collected from breed if the frequency, meaning how common the mutation is in the population for this FGF4 retrogene in chromosome 12, if the mutation rate is at least 5%, so the allele frequency is 0.01. This mutation is dominant, so that already one copy of the allele, one extra copy of the FGF4 in chromosome 12 increases the risks for the diseases that it causes. And as I told you, Vilma is going to tell you about this. You can find the full list of the breeds where this FGF4 chromosome 12 is found from the US Danish panel. The link is there. Breeds with high frequency, which means like 70 to 100%, include all taxons, all varieties. Frequency is 2.9, which means 90%. Then Cavalier King Charles Spaniel is the highest. There is everything. Disease in this breed, I think. French Bulldogs are also relatively high. Beagles, even though you would not think about it, but beagles are also kind of a chondrodystrophic and dystrophic, and they have a high frequency of this mutation. And so are also the English Cocker Spaniels.
I also think you could use that.
There's a
Yes,
this one.
because
And there are breeds that you wouldn't think.
Yeah.
For instance, English Springer Spaniel is also having this mutation. And I think that it comes from the history of these breeds. So you have to go back to the history to trace where the retrogene might have come to the gene. The frequency of Skye Terriers is 0.77, so 77% of the Skye Terriers have this mutation. But it means that there are dogs that don't have, or have only single copy. And it means that it could be bred to and out from. But then of course we have to take in consideration that if we are leaving 77% out of the breeding program, we are left with nothing. So it cannot be done like that. But then one interesting feature is that the frequency in Scottish Terriers is 0.04, which means that only in 4% of the Scottish Terriers there is this mutation, which means that the short leg phenotype in Scottish Terriers is derived from the chromosome 18 mutation only. Lucky them, lucky you. And the breed, therefore, is not prone for this invertebrate diseases. Why genetic testing? Why should Skye's be tested for this mutation? My God, I'm tired. Okay. US Davis data and also the wisdom panel data, there are not so many, there is not public information for the wisdom panel because they are not listing the breeds where there are so little test results. And this is the problem with Skye's. We have so few test results. And we should get more so that we could go to these lists and see actually what we have. And this is the reason why we should maybe start to systematically, more systematically genetic test for this mutation. So anyway, the US Davis data shows that we do have dogs that are heterozygote, so they only have a single allele. We might even have, if we are lucky, a dog that doesn't have this mutation at all. But then most probably has some other disease. If you are a pessimist, you are never disappointed. Okay. But as said, the numbers of tested dogs is too low. And we cannot at the moment fully determine the allele frequency in the breed. This is the 0.77 is only an estimation. So we should test more dogs to get more reliable results. If we do have dogs that are heterozygote or even have 2 wild-type alleles in chromosome 12, these individuals would be used for breeding, if other measures, of course, are okay. Used for breeding, despite of that they might not be world winners. So we have to compromise in some things to get something. And I think that the health, nevertheless, is the most important thing. What if the ears are perfect or the tail is perfect? What are next steps then? One possibility is try to start to avoid the mutation. But, as said, we have too many dogs most probably who have this mutation. This is a disease gene for sure. This chromosome 12 mutation. If we would have more normal individuals without this mutation, it would, in my opinion, improve the health status in the breed as a whole. This is one of the diseases and mutation that is also now in the forefront when breeding restrictions in different countries are planned and in animal welfare legislation.
We already have that.
Yes.
In Denmark, on the 1st of July.
Yeah, and we are very afraid of what happens to us next year when our ministry
Well, don't be afraid. I'm in the group that is planning.
How would you
I'm in
fight hard
the
for us?
ministry. I'm in the Ministry of Agriculture group that is planning these measures.
Thank
But-
God
but-
we are.
And if I can say a little thing, we were upfront in that. So we are lucky that no breeds were banned because of health problems in Denmark, because our counter
made a great effort for the Danish politicians to say, look, we already are ahead of this. We already have a plan, so therefore we didn't lose breeds because of health issues.
Exactly. This is the reason why we have this. We have to have these plans.
Yes.
We cannot just be like, okay, we are waiting the heaven to fall on our heads. We have to make these plans, and we have to show that we are able to do things. And this is the reason why, for instance, I think that it would be extremely important to make this genetic testing. But the genetic testing doesn't tell if the dog is going to have the invertebral disc disease. But Vilma talks you then later on what are the consequences and what are the possibilities. And then it's not only in Denmark, it's not only in Finland. I'm also in the book that is giving opinions about the EU legislation, there's European Union legislation in dog welfare, health and welfare, especially in dog health and welfare, is going to an action.
Yes.
And then, wait, it comes to Australia, wait, it comes to United States. I mean, when this kind of things are starting to roll, and every good and bad thing has started in Europe in this history of life. So you will eventually also join the gang. And then people, the public, thinks that we are idiots because we are breeding dogs that are not healthy.
And there are votes for the politicians to slam
Yes.
the purebred dogs because, yeah.
But I think the authorities in Scandinavia, they already have good organization actually, so they don't take up that much of these.
No, but you still have to work for it.
Yes,
Because,
absolutely. And we have to show the politicians and we have to show the public
Yes.
that we are able and willing to do something.
And
We are not just sitting with our bottoms and doing nothing.
Because the authorities will actually support it if they have a...
Not all of them. No, because I know a few politicians that will not, because they think there are more votes in the public.
Exactly.
Yeah, but they
are
that's
sitting
not the
on
authorities,
votes.
that's
They
the
don't-
parliament.
If we get a new government in next year, then we were fucked if we didn't have this law this year. Then we had the same situation in the
Politicians
Netherlands.
are politicians.
Yes.
Have you noticed something lately in the politics in
Yeah,
this
but
world?
still they have difficult to turn around the authorities which are in charge of these different tasks.
But we cannot rely on politics.
No, we cannot.
No,
No.
but on authorities.
Okay, but then it has to be remembered that we also have other problems than this.
Yes.
And low number of dogs is one of our most threatening problem. And thus the low genetic diversity. But I'm talking about that later on this afternoon. X-rays for this ink, as said already, highly recommended. We have experiences. We have now more than 100 X-ray dogs. How 3200, close to 200. Close to 200, which is important. We can start to soon calculate indexes,
Yes.
estimated breeding values.
And I think E1 is the result. So unfortunately both aims like E0, which is there, as also low appearance, as is E3. So the average E1
Yes,
is
yes.
both aims.
Yes, but when we started, I think there was one dog that had normal,
Yeah.
completely
In the
normal.
first
We had one in 50, and now we have more.
Now more and more dogs with 0 results, which is great. So this tool really, it works.
And as I said, it's not normal for a puppy to be limping. It's a sign of pain. Puppies should be able to run and enjoy life and not be created because of limping. Puppies should be happy. He had the most terrible elbow joints and front. But he wasn't limping. But he had the most terrible. Anu Lappalainen, who is a colleague of Wilma and started this all, she always said, Turo is my role model, really my dog. Because it was terrible, but still he was happy. Yeah. Questions? This is my first Skye Terrier. Yes, Venus of Skyline. And now you know why I like dark pigmentation in creams. Actually, what is the recommended age? What would you recommend, Vilma?
I think you can X-ray the elbows when the dog is 1 year old, because I think, well,
Usually we do it after 2 years of age. And the dog comes to the breeding
I
age.
think this is quite big dog, so because I have golden retrievers, I usually say to my like what I have been breeding, that maybe 5 years old, that when they are fully grown. But I think this is, you can do it when the dog is 1 year old, but of course the possible osteoarthritis will affect the evaluation. So when the dog is older, then the evaluation is of course more sure, because if it gets osteoarthritis, it gets it more probably when it's 2 years old. I think that's wise to advise also.
And we are not X-raying for elbow dysplasia at all, these breeds which have the chondrodysplasia. I mean, it's because it doesn't tell you anything. Their problem is not elbow dysplasia. This is their problem. We are not X-raying. Actually, it's not well, you can X-ray, but the scrutinizers don't give any evaluation. So we have a list of breeds that are only getting this evaluation and not elbow dysplasia evaluation anymore. And we are using the same list in all Nordic countries, which are doing this.
And the list can be found on the Finnish page, or the list of
Yes, we
breeds?
have the list of breeds. Yes, we can provide it to you. And there are some new breeds added to the list, and then they are taken away from the elbow dysplasia list.
When the puppy is limping, is it only, do you mean only the front legs? And how do you call it when the back legs are moving? I know something with the knees, but when they are nothing with the
Well,
knees.
that's very interesting. And you mean puppies?
Yeah, puppies until 6 and 7 months.
That's very interesting, because we have been discussing that this chondrodysplasia most probably also has an effect on hind legs, not only on front legs. And for instance, in Dachshunds, of course, there is this new type of anomaly which is known as Vesvarus, and they have a like their hocks are turned outwards, and it can be milder, and then when it's really severe, I mean, the dog cannot move. And of course it is also causing abnormal movement, but also limping hind legs. And I know that there are many dachshunds, not many, but there are dachshunds that have been put to sleep because of this specialized. And I think that it's not only the dachshunds, but there is not enough of research yet done on this subject, but there is more coming, more research is going to be done, and then we also know that this is something that might be also seen in our. But looking at the Skye hinds yesterday, I can say that the problem is not turning out, but turning in.
And another question is, most of the doctors in Germany, they said when they have got legs outside like a Chippendale, you must operate the Skye when he is a year, maybe 1 year and a half.
You mean operation of radius?
Yeah.
Yes, well, there are puppies that for sure benefit of the operation. But it has to be first evaluated if the operation is beneficial. And then it is absolutely necessary to have the puppy operated in that phase that the growth plates are not closed yet. Because if they are closed, you cannot have the bones back to normal. But there are Skye puppies and also other breeds that have been operated, and they will benefit of it. Their life becomes more.
Yes,
But it's the better. First of all, it has to be looked how the elbow joint is looking at, what is the ink status, and then how severe the limping is, how long it takes, and then it's like a evaluation of the surgery. Surgery is who is doing it.
Most of the veterinarians in Germany, they want to save money, and they are operating so soon. I always said, don't do it.
But I mean, soon. But you have to do it in time, because if the growth plates are closed, if the bone growth is stopped, there is no way to, or the dog cannot get the benefit from the operation anymore.
That's why.
So this is the reason why the surgeons and orthopedists, they want to operate it in good time, because otherwise it's there is a quite short window.
And when it's done when it's younger, you can operate from a different place, from more distally, and it's like a better way and not so like the prognosis is better if you do it sooner and distally, and when it's older you have to do it proximally, and that's more like a unsure way than to operate anymore, and the prognosis is not so good anymore.
The prognosis is not so good, and the healing process and everything takes much more time.
So what's the age for the operation? If it has to be done?
Of the window.
Yeah, what's the
Well, it's also the evaluation of the status of the growth
It
plates.
depends on the dog, because I sold a puppy that got operated in Ireland, and she was 9 months old, and she's 10 years now. And
This is okay.
Yes.
Yes. Yes. Yes.
So how long she was sleeping before the operation? Can you remember?
Not that much, but they had a very good vet who was in contact with me, and they sent x-rays to my vet, who was exceptional. And he said, this one I will operate. He also had another Skye from another breeder in Denmark that he evaluated and said, no, we don't operate that one. It won't benefit from that. It will live a good life without operation. And this one got operated as 9 months old, and she is 10 years now. There's no
That's,
So you cannot really say that,
No, no.
and that's why it's so important that if your puppy starts to limp,
Yeah,
you go and take the puppy to the
Yeah,
X-ray,
yeah.
so you can see in what stage the elbow joint is, because the time frame is so small to operate.
And
So-
that is why I hate Facebook groups where people ask other people that my puppy is limping. And then they say, oh, you need to have it stay quiet and trade it and everything. And I was like,
And then, for instance, the social media is full of these questions from the puppy owners and also from different breeds, not only Skye Terriers. And then breeders say, don't operate, don't
because they don't
operate,
want
don't
to,
operate,
know
don't
the
operate,
truth.
don't operate. But the first things first, we have to first think about the health of the dogs and then other things secondary. Of course it's costly, of course it is takes a bit of time and effort for the healing process, but then when the healing has been done and if the prognosis is good, the dog will live normal life without any pain in this elbow joint.
Just a quick question. We recommend with our puppies that we don't, people who get puppies from us, they don't let them go up and jump up and down stairs, and that while the growth plates are closing. Do you think that's a good recommendation, or it doesn't matter?
Well, I mean, but it should be taken like in every puppy. You have to be a bit cautious with every puppy so that they are not going like an idiots here and there. But I mean, it's, as said, it's not something that is causing the incongruity if the puppy is jumping and running.
Yeah.
It is
that's-
inherited problem.
Yeah, that's true. I have had some zero result dogs and you can't do anything with them. They don't break down.
Okay.
Yeah.
And you don't.
So
you-
it's
you don't.
definitely.
But then, if the puppy starts to limp, of course, then you have to be maybe a bit cautious. And they are. I mean, it's a sign of pain. Limping is a sign, and then limping is also funny in that sense that if they start to limp both their front legs, you cannot really see that they are limping because they are.
I tried that.
Yeah.
And it was from the same year that it was horrible. And he was going to Sandy, actually, to Australia, and so I kept him on. And then he never played like the other puppies. And he was always lying down, and I thought always a quiet puppy, but then suddenly I got a bad feeling, so I took him to the vet.
Yes.
And the elbows were,
Yeah.
he was going to sleep.
Yes.
And that was because it was the both legs.
Yes. 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 Because you cannot operate.
No,
both
no,
legs.
no, 6 months old.
Yes.
Sorry, with those ones that have had surgeries, would they be like E3 or even worse, or they would have been X-rayed first?
Well, at least when I have been talking with Anu, most of the cases are like the severe cases. But then there can be also dogs that are limping that has like grade 2, even grade 1. Vilma, what is your
Yeah, I
experience?
think it's usually they are more severe, but you cannot say that
Yes.
it's kind of
Yeah.
really like doesn't have symptoms because of the radiograph, because the radiographs and the symptoms doesn't always go hand in hand.
I think it depends also on the inflammation
Yeah.
somehow.
And this is anyway like many of these things, even though the FGF4 mutation in the chromosome 18 is the one that is responsible for this abnormal growth in bones. This incongruity doesn't occur in every chondrodysplastic breed. And Skye Terriers were like the epitome of this puppy limping when we started. And then we were like I'm not cursing, but I was almost saying. But anyway, we had to get rid of this somehow. And there was no way that we could get rid of this because the elbow dysplasia X-rays didn't tell the story. When the elbow dysplasia X-rays were taken from these puppies or these dogs that had been limping and had these elbows outside from the joints, so they got grade 0 in elbow dysplasia assessment. So I mean it was no use to do that. And then I think that the vets already know quite much about this, how these X-rays are done, but as said, we can give you instructions, and then Vilma and Anu Lappalainen are those who are in Finland scrutinizing these, and
Liisa is also.
Liisa is doing, yes, the vet who works the kennel club. So if you need evaluations, they are not doing it for free, though. But it's the least of your problems, the evaluation, the price of the evaluation.
And it's also important to remember that if the puppy is not limping, it's not a sign that there is no problem.
Yes,
Because we need
exactly.
to remember that they are individuals. Some of them do show the pain, and then there is dog individuals that you can almost put knotted and they don't give you any sign of the pain. Same with us as humans. Some of us are very sensitive for all of the pain, and some might be running with broken joints like crazy, with no signs.
So where is the pain coming from if it's in one?
I think usually the pain is related to inflammation and the cartilage like damage. It's the one thing that you have to remember when the dog has pain, because the cartilage damage and the inflammation is the one that develops the osteoarthritis, and then that's why you have to stop the limping in some way, because it tells you about that. So that's I think one thing with these limping puppies.
Yes, because if it continues limping, it's funny because it can be at times so that it stops limping, but then it starts again, and it's the same problem. So and if they are having this inflammation in and the cartilage is gone, so goodbye elbow joint.
And when this project started 15 years ago, perhaps half of the first population got 2 or 3 results, and now most of the dogs get number 1 results. So our fronts
They have improved.
Yeah, much. So it works. And now it's not so uncommon anymore to get to 0 results as well.
But how it works, it's one thing is testing and
We do the selection.
selection.
Yeah, selection.
Because this is important to say.
Yeah.
It's not only the testing.
Yeah, we do.
No, wait, well, I come back to that when I'm talking about my second subject. So, I mean, whatever you are doing, genetic testing, X-rays, whatever health result, it doesn't help if you don't select also for the results, because there are of course many aspects in selecting the breeding stock, but health is not something that you should compromise for.